We want to find the area bounded by these two curves. Now, straight line, right, crossing at 11, and a parabola opening upward because it's positive, crossing at 5. So we have a way of doing this, right? What we're going to do here is we're going to say that the area is equal to the integral. Now we're going between 0 and 3 of, okay, we're going to have f of x minus g of x dx. But now this is a general formula. What we need to do is define which one of these is really f. Just because this says f doesn't mean that it's this one here. And just because this one says G doesn't mean this is G. Keep in mind when we read this formula, this is the top of the rectangle. This is the bottom of the rectangle. So we need to decide which curve lies above the other. Now, I think you might see it in this case because look, we've got a straight line that crosses at 11. This is a parabola that crosses down here at 5. So this curve here is above this curve. So in this case, it does turn out that f of x really is this one. G of x really is this one right here. Now, I used a program called Desmos. I'll write it down here at the very bottom. Desmos. It's a free graphing program, pretty easy to use. We don't really need to do that, but that's what I used in order to get the graphs, just so we can visualize what's going on. And what we're looking for is this area bounded by those two curves and the line 0 right here and the line 3. And if I draw a representative rectangle in here, I can see that the top, right, here's the top, that's coming off this line, and here's the bottom, that's coming off of that parabola. And just to be sure we understand what's going on here, what have we got? It's the area of the rectangle, and then the integral just adds up the infinitely many rectangles that we're going to put in here. So what's the area of a rectangle? Well, it's the height times the base. Now what's the height here? The height of that rectangle is going to be the top minus the bottom, and the top is that x plus 11 minus the bottom, which is the x squared minus 5. So that's what I've got right up here. Right inside here, that's the height of the rectangle. And what's the base? Well, the base is that little delta x, or dx. dx for infinitesimally small base. So that's this right here. This is the base. So you can see in the formula what we're doing is we're adding up infinitely many rectangles from 0 to 3 of the heights of the areas of those rectangles, right? The height times the base. So that's the theory behind what we're doing. Let's get to it and actually do this. This is the integral 0 to 3 of, let's get rid of those parentheses. How about x plus 11 minus x squared plus 5 dx? We can simplify a bit in here, right? So the area, how about the integral 0 to 3 of, now I'm going to write it this way, negative x squared plus x, and then the 11 and 5 is going to give us a 16 dx. So the area is, now how about this, negative x cubed over 3 plus x squared over 2 plus 16x from 0 to 3. So to get this area, let's put in the upper limit. So we are going to get negative 3 cubed over 3 plus 3 squared over 2 plus 16 times 3 minus, now put in the lower limit, but look, all these three terms, all the terms have an x in them, and we're putting in 0. So zeros everywhere, so we're just going to get a 0 out of this. And then I'll do it up here. When I did this, I just did this on my calculator, and I ended up with 27 over 2 as the area, or if you like, you could write, I suppose, 13.5.